Good evening, dear student. You would have listened about various types of the forces like electric force, magnetic force, mechanical force. Today we shall discuss a special kind of force that is always attractive, and this force is gravitation. You're all familiar that when a stone is thrown vertically upwards, it falls back to the surface of the earth. Do you know that moon revolves around the earth? And in fact, all satellites revolve around their planets. The planets revolve around the sun. What are the forces which are responsible for these phenomena? Today we shall try to find out the questions of these answers. So let us see what is gravitation. Every body, in fact, every particle in this universe attracts every other particle with a force. This force is called gravitation. What is gravitation? Gravitation is an attractive force which acts between any two objects, any two bodies, any two particles having mass. This gravitational force between two masses or between two objects depend on two factors. Number one, masses of the two bodies. And number two, distance between them. Isaac Newton carefully observed the factors which govern the gravitational force and generalized a law which is known as Newton's universal gravitational law. It states that gravitational force between two bodies is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. This force always acts along the line joining their centers. Let's see. Universal gravitational law states that gravitational bodies or two objects is directly proportional to the product of their masses and inversely proportional to the square of distance between them. Means the gravitational force between two bodies will be greater when the masses of the two bodies are very large and the distance between them is very small. On the other hand, this gravitational force will be very weak if the masses of the two bodies are ordinary, very small, and the distance between them is large. So, we can derive formula for the universal law of gravitation. Consider two bodies of masses m1 and m2 are separated by a distance d from their centers. There are two bodies. Masses of these two bodies are m1 and m2 respectively, and they have been kept at a distance d from their centers. Now, according to Newton's law of gravitation, gravitational force between two bodies is directly proportional to the product of the masses of the two bodies. Right? And the second part, the gravitational force between two bodies is inversely proportional to the square of the distance between them. That is, F inversely proportional to the square of the distance between them. Now, combining both equations, we have m1 into m2 over d square, or F is equal to G into m1 into m2 over d square, where G is a constant of proportionality which is known as universal gravitational constant. Its value is 6.673 into 10 raised to the power minus 11 Newton meter square per kilogram square. So this relation is mathematical expression for universal gravitational law. F F is equal to G into M1 into M2 over D square, where M1, M2 are the masses of the two bodies respectively, and D is the distance between their centers. Now, Newton's law of gravitation is known as universal law of gravitation. Why? This is because this law is valid for all the bodies in this universe. This law is valid for all the objects on the earth. It is valid between earth and the moon. It is valid between earth and the sun. It is valid between any object in this universe. Hence, it is known as Newton's universal law of gravitation. Now let us define universal gravitational constant. So, F is equal to G into M1 into M2 over D square. Okay? Now, if M1 is equal to M2 is equal to 1 kilogram, D is equal to 1 meter. That is, the two masses under question have mass 1 kilogram each. And the distance between them is 1 meter. They have been kept 1 meter apart. Now, substituting these values in this relation, we have F is equal to G into 1 over the square of the 1, that is F is equal to G. So what is G? Universal gravitational constant is numerically equal to the force in Newton between two objects of masses 1 kilogram each, and which have been kept 1 meter apart. Universal gravitational constant is numerically equal to the force of attraction in Newton between two bodies of masses 1 kilogram each, and which have been kept 1 meter apart. This is all today's. Thank you.